Thanks for joining us all for this first recording. I'm here with just Bram this time around, and we're going to talk a little bit about Chialisp and about various things related to it and the thinking behind the creation of Chialisp. For those who aren't fully aware, Bram is both the co-founder and CTO here at Chia Network, and Chialisp is kind of his brainchild on how to basically look at everything that's been done with smart contracts and programming on blockchain that we've learned over the last 13 or so years, and thinking about how could we do it differently if we knew then what we know now.
I wouldn't say Chialisp is just my brainchild. It's
not just, no.
Yeah, there's a few different people have had input into it, including very much Bitcoin lore.
Yeah, which is exactly some of the stuff we're going to get into later today. So with that said, we'll get started. We have a couple questions folks have submitted to us through Twitter over the weekend, as well as questions have come in from other places like our Discord and other stuff. To start all this off, to set the tone for the conversation, can you explain a little bit in fairly simple terms what Chialisp actually is and why you spearheaded creating a new on-chain programming language specifically for the Chia blockchain?
It's a little hard to know where to start. I've at times given talks on the environment and spent an hour and barely scratched the surface.
What is the 5-minute version of that?
5 minutes. It's a little hard to say. So
I'll give you 8 minutes.
I can explain rather briefly the overall view that it has of things, which doesn't even touch on Chialisp, the language per se. So there's this question of what is it that's being stored on chain, right? You have a blockchain is a secure distributed database. That's the whole point of the exercise, is to have this secure distributed database. Different ones of them store different things. Coin is in what's called the UTXO model, where it remembers what amount to coins and their values, and that's it. And Chia is in the coin set model, where it remembers literally coins and their values, and that's it. There's a bunch of extra crap that was thrown in there in Bitcoin, thinking that it was good for security, although a whole lot of that, it turns out, is a bad idea. So for Chia, we had a lot of benefit of hindsight and existing academic literature and other things, and we're able to figure out what exactly should coins be, in particular, what information should be included in a coin to make it a useful thing. And it's mostly a massive dumbing down of what coins look like in Bitcoin. And it's very different from the direction taken by Ethereum, where what's stored on chain is actually very rich data structures of including JavaScript programs and objects, which can then be called, which has the benefit of being Turing complete, and you can in principle do anything in it. It has the massive disadvantages that it's not a very efficient way of doing things. And also it leads to everything being these walled gardens of functionality, that things don't just straightforwardly interoperate with each other. Where Chia gets the benefit that since everything is a coin, it's like how in Unix everything is a file. It makes it so that everything can interoperate and everything is extensible because they all speak the same lingua franca and have the same approach to doing things. That's the briefest summary
Okay.
of what's going on.
So in that, you talked a little bit about other models of chains that are out there.
Yeah.
And so in that regards, a blockchain programming language is not a novel idea with Chialisp. We have things like Solidity or Bitcoin script. What specifically are advantages that Chialisp was designed to offer developers they can't get from those environments?
Yeah. If there's any one big motivating thing behind it, it was having an interest in being able to create colored coins. So in Bitcoin, you can have colored coins and colored other things. This is the basis of Omni protocol. It's the basis of, what are they calling the NFT protocol they're using now? I'm forgetting the acronym.
Ordinals. Yeah, they're called
Ordinals. Yeah, it's the basis of Ordinals, which is some of the code for Ordinals was taken from Chia. But those things require running a full node in order to do them. And what you would ideally like to do is make it so that your actual transactions on chain can validate that they're talking to legitimate colored coins, particularly for tokens. You want to know not only does this thing claim to represent this amount of this other token, but its coloring is legitimate. It really is this thing that it claims to be. And that's called a capability in the parlance of security things. It's really not obvious how to do that. And actually, almost everybody has been going in the exact opposite direction, that they start coming up with extra forms of metadata, extra things that can be put onto the blockchain that are metadata that explain capabilities and have very specific semantics about what they support. And I figured out one weird trick, which makes it so that you don't need that, and designed the entire system around enabling this one weird trick. It takes more than a few words to describe the one weird trick.
I welcome you to try. We have plenty of time.
Yeah, I can try. I'm always trying, but it's hard to convey the whole thing. There's this thing that happens where people are confused by this thing when they first see it, particularly if no one holds your hand through it. If you just sit down and read the spec, it's mystifying. When we say Chialisp, it does refer to Chialisp, the language, but it also refers to CLVM, the virtual machine environment, Chialisp, the language that gets compiled into CLVM code, and the format of coins and the semantics of the blockchain, and the conditions language that has to do with coins getting spent. Mm-hmm. And this whole broader ecosystem we refer to as Chialisp, without being terribly specific. The whole thing works together. And the benefit that a Lisp type language brings is everything is completely sandboxed. When you're doing stuff in this environment, you want sandboxing as a basic feature, and you want self-reference. It's a really normal thing to take a piece of code, validate it, and then even though it's untrusted code, call it. This is a really normal thing to do. And rather than take a language that wasn't designed for this from the ground up and smush in sandboxing functionality, we decided instead, and this was Richard Kiss's suggestion because I was unhappy with all the ideas I had for sandboxing, to just use Lisp, where everything is sandboxed all the time. Mm-hmm. And it's a language that's designed almost for self-reference. So this is a really normal thing to do in Chialisp. Much unlike even other Lisps, it's not totally normal to do this. Because a lot of Lisps wimp out and aren't absolutely pure, where Chialisp is totally pure, has no side effects whatsoever. The trick here is you want capabilities, right? Oh, I was saying that when people just sit down and read the spec of how CLVM works and how coin spends work and how the conditions language works, it's, wait, this is a joke, right? This is brain fuck. This is not a real language. What are you talking about here? And if you don't know the tricks, it's really unusable. If you do know the tricks, it can do a lot, but you must use the tricks. So the basic trick here is you want capabilities. There's two things. You want covenants, which are restrictions on coins getting spent in the future, and you want capabilities, which is the granting of extra capabilities to things in the future in a way that's not forgeable. And covenants are reasonably straightforward to add, particularly when you have a Turing-complete language. So the basic construction of coin IDs here that enables everything is the complete structure of a coin ID is it's a hash of a coin. And the structure of a coins string that describes it is it has a parent hash followed by a puzzle hash, what in Bitcoin parlance is called a script pub key hash. It's there's a program that must be revealed and be passed a solution in order for this thing to be spent. And then there's an amount. There's the amount of Chia, or specifically the amount of mojos that this is worth. A mojo is 1/1,000,000th of a Chia. Yeah, so it's to the point where technically speaking, really it's defined the other way. A Chia is 1,000,000,000,000 mojos. But
relatively speaking, we don't actually deal in Chia, we deal in mojos. Chia is just the more easy to reference whole number. Yeah.
Yes.
Like we deal in dollars, US dollars, but it's measured in technically
and pennies.
Cents.
Yeah. Sometimes fractions of a penny, which are always decimalized. But yeah, there was actually a funny point in history where they started on stock markets. They went down to, they were initially only had the granularity of dollars, and then they added in granularity of half dollars and then quarters. And then they went down to granularities of 12.5 cents.
Okay.
Obviously, that was a bit painful. They later switched to it being based off of pennies.
Yeah, I feel like once you get below quarters, why go anywhere else with pennies?
In trading markets, they're often very liquid, and they're trying really to avoid arbitrage opportunities.
Right.
So if you're trading, if you're arbitraging like dollars to pounds, say, across multiple international currency markets, a difference of a penny in value can actually be a lot if you can trade $1 billion worth of it in a couple of minutes.
Very true. Very true. Yeah.
Which often you can. So that's why you have this tremendous level of granularity, because the markets are efficient enough for it to actually make a difference.
Yeah.
And definitely if you're like exchanging, if you go to a foreign country and you exchange even like $1,000 for whatever the local currency is, you care about losing 1% of it.
Right. Yep.
In the trade. So that level of granularity very much makes sense. Possibly even quite a bit smaller than that makes sense. So anyhow, $1 trillion is perhaps excessive, but is pretty reasonable when you're trying to do colored coins and want to be able to specify reasonable amounts of colored coins. In fact, we have this convention that the units of colored coins are in thousands of mojos.
Mm-hmm.
So if you have some colored coin and you are describing the amount of it that you have, you take the number of mojos it is divided by 1,000. This way, if you have 1 Chia of potential melt value, you can make 1 billion of your colored coin. And this allows you to still have a fair amount of granularity of your colored coin without it costing you a lot of money and melt value to create it.
Which makes sense, because given the fact that in Chia, everything exists as a coin in some form, and that coin has to have a value, at least a minimal value. If we reached a world where the value of the coin was significantly high for 1 Chia, you still want the barest, most minimum value that a NFT or a token or a transaction or a some kind of programming function to be. It needs to be not astronomically high cost.
Yeah, I actually considered not having the amount be listed and making the amount actually be a capability, both in terms of what's for native tokens and for the CAT standard. But everyone thought that was a little too crazy. That was a little bit much. So this method of naming coins, and this relates to the method of spending coins. So to spend a coin, you need to give a reveal of its puzzle. So you give some CLVM program which hashes to the puzzle hash that was given. And then you give a solution to that. What a solution is, and in Bitcoin parlance, the solutions are called script SIGs, which is a vernacular that only makes sense to cryptographers. And yeah, we call them solution. So you give a reveal of the program. The solution is then passed to the puzzle, and this is run on chain, and it returns some conditions. And the conditions language is extremely simple. It's not a real programming language at all. It has a fixed list of things it can do. It can most importantly create new coins. It can also enforce time locks. It can create announcements, which is messages to other coins. It can require announcements from other coins. It can assert its own ID, because self-preferential programming is really important here. It can pay a fee. These are the very basic things that it can do. Yeah,
go ahead. Go ahead. Oh, so I was going to just redirect a bit. So
yeah,
to approach the same previous question from a different angle, and that's not because your answer wasn't good. I'm trying to get two kind of frames to this.
Yeah, it's for me to give an answer that doesn't meander for a long time.
It's totally fine. It's totally fine. That is one reason why, even though we're doing this live, for the folks who are listening right now, the version they hear on the recording will be different. It will be edited. So nothing to worry about there. But to approach it from a different angle, not to pick on Solidity, not to target them specifically, but they are the most ubiquitous language out there for smart contract programming. To use them as an example, what is a reason why Solidity isn't good enough to do the things that you can do with Chialisp? That really makes Chialisp stand out.
A really basic problem is that when you have an ERC20 token, this is not a real set of coins, right?
Mm-hmm.
It's not it's a database on the database that's just remembering everyone's balances. But if you want to have smart contracts for this thing, this gets extremely awkward. People have these hacks where they loan out the funds to other things that kind of keep track of them, but it's not like a first-class thing where fairly directly any sort of smart contract that you have for your basic functionality can be easily ported over and work just fine for colored coins as well. It requires massive layers of hacks to make anything like that work. And in general, even for simple things like custody solutions, they wind up being like a contract that just remembers what everyone's doing. And it's very unlike the way you do that in Chia, where everyone's coins kind of reference probably similar code to get some efficiencies of sharing similar code. But it's all very much sitting within their own coins and can be pulled out individually and don't have these monolithic things overseeing them all.
Okay.
Yeah.
So with that in mind,
but there's also another thing, which is just general reliability and auditability.
Yeah.
Solidity is horrible for that, just in terms of how it works.
Yeah, very true. I mean, if you just look back in the history of issues where there are issues with Solidity smart contracts that always come down to a missed issue in them and someone audited them, sometimes multiple people audited them and still multiple people missed them because it's just...
Yeah, there's a lot of implicit stuff going on in there, and it's all very scary. It's not like you can't have problems in Chialisp. We have. The list of potential gotchas is much shorter, and the ones that we've hit have been actually not very scary. Like, scary things are when you have a problem where you have an off by one error or a buffer overflow or things like that, which are very easy to remake the same mistake again in the future. And the problems that we've hit have been, for the most part, like basic conceptual oopses that are very easy to just permanently avoid after you've been bitten by them once.
Gotcha. So with all that in mind, looking at what's potentially out there, what applications already exist out there in other ecosystems or applications that exist on Chialisp already, do you have any specific examples of a kind of application or a specific application that you think that Chialisp is particularly very well suited to solving for over other options?
Yeah,
I think I know what this answer is. I think I know what the first answer is.
Yeah, there's a whole bunch of things to answer here. There's a whole difference in focus. Solidity programming tends to be very focused on Z-like things, on investment vehicles, where Chia stuff is much more focused on just being a good accounting system. So our beachhead product right now is a combination of having cats. There's our colored coin standard is called the cat standard. And in particular, a feature on top of that where we have offer files, right? So you and I can engage in an actual peer-to-peer trade of things, that I have a certain amount of cats and you have a certain amount of some token like Stably or something, and we wish to trade. So what I do is I make an incomplete transaction that prints, I'm sitting on some Chia. So I make an incomplete transaction that prints a bunch of Stably and just makes a bunch of Chia disappear, just retires it. And this is not a valid transaction because you can't just print Stably unless you're Stably themselves. You're just not allowed to do this. But I can make a partial transaction that tries, right? So I then send this to you and you can decide, oh, I would like to be a counterparty to this. And in fact, this is safe. I can post this to like 4chan and stuff, like wherever. I can put it on Passenger Pigeon. I don't really care if somebody intercepts this in the middle, except that I might want to give you first crack at it rather than...
I want to see someone on Twitter show us actual confirmation that they successfully shared and completed an offer file via Carrier Pigeon. That would be the most amazing thing.
Yeah, that's entirely doable because you can fit an offer file in a QR code.
Exactly. And you can put a QR code in those little tubes. So I want to see this happen. I really, truly want to see this happen.
Yeah, this should be actually pretty straightforward to do. The hardest part is getting your hands on working passenger pigeons.
Yeah.
They called passenger pigeons or is it passenger pigeons?
I think they're carrier
pigeons.
Yeah. The thing is, it's a very esoteric, specialized hobby. And our community of developers tend to trend towards the more esoteric, nerdy people who have their deep, passionate hobbies that are a little more atypical. So I feel like somewhere out there's an intersection.
Yeah, I don't know. Maybe Mike Tyson will do it for us. He's into pigeon breeding. Although he is not, to my knowledge, into Chia. But it would be cool if he did that. So now I might want to give you first crack at this offer. But if I don't care who takes it, I just want it taken, I can post it publicly. And then anyone can take the other side. And I have the guarantee that the worst thing that can happen to me was that the market moved in the interim. while my offer was pending. But that's it. And I can rest assured people won't steal my money if I do this. And you take the other side of the thing by doing a balancing thing. You make another thing that prints a bunch of Chia and retires a bunch of stably in exactly balancing amounts, and then you can smush these together and introduce it to the blockchain with no further interactions from me, and it will go through just fine, assuming that no one else had already taken the offer.
Right. You just wake up one day and find out you have more stably than you had the night before, and you have less Chia than you had before, and go, oh, I guess someone accepted my offer at some point.
Yeah, and this actually, you can even market make this. If there's an arbitrage opportunity between multiple offers, someone can smush them together and take the spread.
Nice.
Yeah. This is really basic functionality. It's really great because it allows for liquid markets and tokens without picking any one favored exclusive venue of trading for them.
And I do have to say that out of keeping one eye on and dabbling in on the retail user side of the crypto markets, going back to the release of Bitcoin up until my time here at Chia now, this is probably one of the most groundbreaking, coolest things I have ever seen in this space, aside from actually the creation of Bitcoin itself. This is a fundamentally very cool feature.
It's funny because it seems like such a basic feature. Like when you look at
it does. When you describe it to someone, you feel like you're describing a table stakes thing or you're describing a basic thing. Yeah, we have offers. You can offer something and you can accept something. Like that sounds like a very fundamentally basic thing. And a person will go, but when you explain to them how it actually works with Chia, I have not seen anyone who truly understands how blockchains work, no matter how much of a maximalist they are of a particular technology love. I've never seen anyone who didn't do that blink twice kind of thing as it clicks and they go, oh, that's cool.
Yeah. Part of the thing is the things I was talking about before, having the interoperability and having capabilities here. So one thing this is very much based on is make it so people can't just print colored coins, that this is simply not allowed. And the trick here to making that happen, and this is the thing I don't know how to explain best, because the way I conceptualize it mixes a bunch of jargon from the security and Bitcoin literature, both of which are obscure to people, and probably some part of it throws almost everybody. But the basic idea is you make it so that you can make a fake colored coin. You're allowed to do it. You can just go ahead and do it. There's no stopping you from doing it. However, it's unspendable. It's bricked, because what these things do is they have a special format of their puzzle, which can be easily validated by others, where this particular puzzle format has this shell around it. And the inner puzzle is like the real puzzle that has the logic specific to the coin. And the shell around it, it's invoking the cat's tail. There's exceptions which are specific to the particular token, to the invariant of the amount of the colored coin can't change. And that tail is its own program. It can be set to anything. It can say this key can change it. It can say this AM can change it. It can say only this one particular transaction can ever make it. These are all valid tails that can be used. But usually the tail is not invoked. The vast majority of the time, you simply say, my parent was a valid cat of this type, ergo I am. I inherited the right to be the amount of this thing that I say I am. Yeah, that's
okay.
That's the basic trick. And because it can introspect and be given a reveal of its parent, it can validate that information.
So one of the next things I wanted to go over, you just very lightly mentioned previously there.
Yeah.
You mentioned the word security.
Yeah.
And when it comes to blockchains and Chia, security kind of has two meanings. There is security in the sense of the chain. There is security in the sense of if I submit a transaction to the chain and the chain accepts the transaction, my transaction will not change later because someone with more clout is able to rewrite history.
Yeah, so finality.
There is the security in the concept of talking about your security stance of the whole chain. Secondly, there is security in the concept we talked about previously about smart contracts, on just having a smart contract that can't be exploited, the actual software security of what you're writing with Chialisp.
Yeah.
So when we talk about Chialisp itself and the Chia network itself as well, what things are there that Chialisp allows us to do to ensure the platform has security in both senses that is strong against a lot of the common vulnerabilities that we see on other chains happen from time to time.
For finality, that's all consensus level stuff. So that's outside the scope of what we're discussing right now. Suffice it to say, we've got all kinds of fancy stuff going on with recent space and time over there, which has been very much proven out empirically to work quite well. Our chain continues to chug along in circumstances which would make proof of work melt pretty badly. So that's working great. The other component is within the language. So the most basic thing is that everything is very simple and straightforward as far as how code goes and has very little weird action at a distance kind of things happening there. So the very most basic thing, of course, is that your persistent data is all coins. And the semantics of those are very obvious. And then you have these other things of having your actual puzzles and solutions not be exploitable. That your puzzles themselves can only be spent in exactly the way that they're supposed to be spent. And a lot of this is done by making it so that it's very simple and very reliable. Like when something weird happens, you just fail. And all the edge cases of things are designed to be as simple as possible through everything. That's I love it. Really a lot of it has to do with you have in Solidity, you have all these problems where there's a function that's like doing something and then it calls out to something else, and people are not following this really basic coding practice of when you have a side effects laden language, whatever it is that you're doing, whatever it is that's going on, you always should clean up your state and finish what it is that you're doing before you make call outs to anything you're going to call out to. And people screw this up in Solidity all the time.
And the analogy, I think, is when you're working on something with tools and you don't put the tool back where you took it out from in the middle of working and you leave the tools lying around. You just left a lot of liabilities laying around that can get...
Yeah, this is far worse than that. This is, even the original DAO hack was exactly this problem, actually, as dumb as this sounds, that you have these things where you are in the middle of doing something and then you make a call out to something else before you reduce your own balance. And that thing that you call out calls back into you to try and pull stuff out. And it looks like it can because your balance is higher than it's supposed to be because you didn't deduct something yet. In Chialisp, this just can't happen, at all, because you don't have state. Whenever you call something, that something can't do anything. All that thing can do is fail or return something. Those are its only options in totality. It can't call you back and modify something or any such chicanery. It has no such option in the slightest. The only side effects that ever happen are coins are spent and other coins are created. And that's it. And then outside of things, time passes. This is something that the conditions language vaguely at arm's length has access to, is some notion of time. Because you have time locks. You can say this coin must be at least sold. You can say it must be at least this time. Things like that. But that's entirely within the conditions language. So by the time the conditions language is getting executed, CLVM has ceased to exist. Like literally when you validate a block, it's done in phases, where the first phase is it takes all the coins and runs all their solutions and figures out what conditions they spit out. It then validates, it then forgets about all the CLVM. The CLVM simply ceases to exist at this point. It was completely ephemeral. The reveal, the solution, the calling it, that all happened just for a brief moment in time, like tears in the rain, and is now gone. And all that you're left with is the conditions. It then validates as many conditions as it can locally. There's some conditions which it just knows, right? Like it can check that the fees are okay. It can check that things that assert their own IDs are what they assert their IDs to be. It can validate that actually there's a slightly higher level here. Then there's a little bit of a higher level where you check the announcements that are made and the dependencies of the announcements. Those can all be done fairly locally within the scope of the validation of the one block. Once all that's done, there's the things that require access to some kind of Oracle information. So you then need to check your time locks, right? Because those require access to time. And in the future, you'll have pretty similar to that. There's access to the randomness beacon and saying things about what the randomness beacon says.
Okay.
But those are held back. By the time those things are getting checked, like the CLVM itself has long since ceased to exist. It's just partially just for scaling purposes. It's holding off on, it makes it so that blocks can be validated completely in parallel, completely on their own processes, yada, yada. And the only thing that's sequential between blocks is the absolute minimum possible. So like when you have a whole bunch of blocks that are getting executed, what the dependencies between them are does the coin set look like after each one? So you want to, as much as possible, boil it down to first validate each block by itself. And each one by itself says, okay, here are the coins that were spent, here are the coins that were created, and here are the time locks for them. And you need to have validated the immediately previous block in order to be able to say that this is a valid block. But you've boiled it down to such a minimal set of information that these can be whizzed through very quickly after all that other work was done.
Okay.
Chialisp is actually a very good scaling solution. Solidity is a horrible scaling solution.
So that is actually something that was literally my next question. My next question was we talk a lot about Chia as a whole, about its amazing scalability. And what part does Chialisp play in that scalability?
Mostly this great parallelization that happens. And this fact that everything that's a deep lookup is constrained to this like one place. It turns out in Solidity, your big expensive thing is doing deep database lookups, that there's something about this like rich persistent state of the system that you need to access, and you need to go digging way deep in something to find it. Or you need to give a proof off the current Merkle or Verkle, whatever is root, of the validity of this deep state lookup that you're doing. And that can be rather large depending on the amount of data that you're talking about here, and there is a lot of data. Or a lookup needs to be done, and that's blocking everything. Oh, and everything is made sequential as well, which is another big problem. Now, actually in Chia, all coin spends happen simultaneously. There isn't an ordering to them, which was done partially just for elegance reasons. Because
when you say that, you're meaning per block, right? When a block is processed.
Yeah, on a block basis. Within a given block, all spends happen simultaneously, which makes it really convenient because you can do things like you can create an output and assert that output was spent at the same time as you created, and this happens simultaneously. Where if there had to be an actual order, you couldn't both create the thing and assert that it was getting spent because it occurs before or after you, so you can only check one of these two things.
And the laws of physics really hate when we screw with time.
Yeah, here having everything within a block happen simultaneously it works just fine. It's clearly the right way of doing things. It actually gets rid of a whole lot of MEV factors right off the bat right there. It's obviously the right way to do things, and it's freaking insane that other people don't do it. It's just like table stakes smart coin stuff, but people don't. I don't know what's wrong with them. That by making it so that you have all this validation can be done locally based off an absolute minimum possible of what's the persistent state, and also minimizing the persistent state. And when you're keeping just like contracts around, you accidentally put a lot of things into deep, rich state persistently all the time. And the cost of creating a contract in Solidity is very expensive as a result of that, because it is expensive. Where the cost of creating a coin in Chia, even with its own custom puzzle, is very cheap.
When you say expensive, for some of the folks listening to this who are not already deep into this kind of stuff and who are actually trying to learn, what do you mean by expensive?
Oh, so the blockchain has a limit to how much stuff it can do, right? In Solidity, the units of this are called gas. So Ethereum is a very flatulent blockchain. Mm-hmm. In Chia, we tend to just call it cost. We don't usually give a name for the units. People have discussed calling it pain or Scovilles or what have you. But there is a unit there. And if you use up too much of that, you've hit your block size limit.
Right.
In Bitcoin, it's called virtual bytes. Or just V bytes, because of everything in Bitcoin is named weirdly for
so basically, when you're saying expensive, what it means is the things you're trying to do in a block, there is a limit to how many things you can do based on the relevant cost of each of those things. Yeah.
And in Solidity, they had this delusion that they were going to get great on-chain scaling, which was always obviously a horrible idea.
The current gas prices speak otherwise.
Yeah. Yes. They thought, we'll just crank up the numbers and get infinite scaling. And it turns out you can't do that. They have, with a lot of effort, made it so that a not horrifically beefy rig can keep pace with the Ethereum blockchain. But it's still not that cheap. It's a huge disincentive to running a full node. Now they have other disincentives to running full nodes. Ethereum's a bit of a mess. But a lot of the problem here is just this constant factor of how expensive is it to just do the basic operations, just in terms of how much resources on a local machine does it take up. And that's just vastly less in Chia than it is for Ethereum, just due to just better engineering. So we can do, it's really hard to say apples to apples between things, not like 20 to 40 transactions per second, which is reasonably comparable to Ethereum, maybe a little bit better. Difference being that like Ethereum requires a real rig to run, and Ethereum and Chia, you can keep pace on a Raspberry Pi. Catching up from scratch from a Raspberry Pi can be a bit painful, but just keeping pace on a Raspberry Pi, no problem at all. And the reason for this distinction is just better engineering. And we could probably make the same trade-offs as Ethereum and crank up our transaction rate by a factor of 10. That would not be a good idea. One, it would be a hard fork, but more importantly, that would create a not that material change in the transaction rate that the blockchain supported, because it's only a factor of 10. It's not going to fundamentally change qualitatively what types of applications can run on chain. And that would make us have, instead of over 100,000 full nodes, we'd be down to 10, which is a trade-off we do not wish to make. So we're keeping things the way they are.
Okay. There's two parts to this question. I'm going to share both of them with you, and ideally I want to cover one and the other, but I'm prefacing it with both because they're related, and I don't want you to wander off into one. And then we follow this up with, okay, now the second question. And then
these are all things where the full, complete picture is very interconnected.
Yeah, exactly. And so these are basically two questions that are very interconnected. I want to give you the chance to talk about one and then weave into the other.
Yeah.
When it comes to building on Chialisp, for developers who've been working with Bitcoin, or more likely working with Solidity and Ethereum, and are considering switching to Chia and Chialisp, aside from, obviously, we have more of these sessions we're going to be doing. This is one of many, and they're going to go into some very specific topics. We'll have guests on who are very specific in Chialisp on certain concepts and topics. Yeah, and we're going to cover certain things. And obviously, there's resources we've put out ourselves about Chialisp. But for developers coming over from places like Solidity, what are some suggestions and resources you would first suggest they look at to facilitate that transition? And then the second question is, if you are someone who is a developer, but you're new to developing anything on blockchain, and you're coming fresh into this, and Chialisp is your first starting point, what is that same answer for that kind of person? If it's different or the same, or what it might be.
Yeah. Having Chialisp as your first real language is a really interesting concept. I think Quex is that sort of animal, which is a really interesting thing to do. That's not going to be most people. Most people are going to be coming from something else. We are very much in the process of improving the resources that we have available. So I right now am working on a very specific project, partially to create this project, but also with a view to create the great new way of doing things moving forwards. That's better. So I'm in the process of working with others to create the great new way of doing things, and do the project that I'm working on in the great new way of doing things to prove it out, so that we can tell other people here, do things this way. This results in a situation that's rapidly improving, but not there yet. So definitely massive room for improvement over what we have currently. So I would say general recommendations are, what you want to do is read through, and I'm not terribly familiar with how we have this organized, read through some of the existing things that we have, right? If you want examples of code, you can read through like the CAT standard, which is like the biggest chunk of code available right now.
Yeah, and it is pure Chialisp, but it's fine.
Yeah. And then the thing that I've been starting with here on this project I've been working on is starting with the Chialisp for it. And I've been doing a fair amount of work on the language itself. So Art is working on the new compiler and improving it and stuff. And I've been doing I write some code And then I whine to Art about how my code doesn't run because I'm using features of the language that don't exist yet. And then he adds those to the language, and then my code runs. So it's a combination of language features and also environment features that we have, like a print statement now, which we didn't before. And we have stack traces, but there's room for improvement on those. There's a bunch of things going on here. There's the nightly builds that Art has put up now of the development environment. Probably at this point, a lot of developers would be better served by being on the latest version of things, because just like the assign by itself is such a huge improvement in usability of Chialisp language that it's a really good idea to get on a branch that has that and start using that feature.
Yeah.
And it also compiles into CLVM, so nothing is broken here.
And one thing we can add to that too, because as I didn't go into this in depth at the start, my developer relations team at Chia is working on example projects that are meant to be a stepping stone from A to Z of the foundational building blocks of building things with Chialisp. You can look at the first component, and the second component is built off the first, and the third's built off the first and second, and they evolve. And not only can you see the evolution of these actual working example processes that you can like follow along with, you can even reuse them as framework scaffoldings to build off of for your own stuff.
Yeah, you're way more on top of that than I am. I'm charging out ahead of everybody.
I try to be, honestly. I delegate that, so my team's more on top of it than even I am. But that is what we're trying to work on doing for that very reason, because like you said, it's those kinds of examples.
Yeah, and there's really basic stuff, like being able to have diagnostic statements, being able to get stack traces when something breaks. These are very basic pieces of functionality that are new to the environment, and we only have in rudimentary form and still much room for improvement.
And like you said, you're way out there ahead of everyone doing crazy stuff. And that's actually good, because you're going to be encountering we can't do this, or, I don't have a way of doing that. You're going to encounter that long before anyone else does, which means long before we realize we need it, which means hopefully we get ahead of people asking for it.
Yeah, a lot of these things aren't really that crazy, but they're things where people who don't have it don't know to ask for it. It's hard to envision what feature it is that you want. And once you're given the feature, it's, obviously this is what I wanted the whole time. But to people who are not deeply familiar with these sorts of environments, it's not so obvious what should be added. So things like diagnostic statements and stack traces are not terribly obscure in other environments. It's just not super obvious where and how and why they should be added to Chialisp and such. The thing that's a little bit behind right now, or a lot behind right now really, is adding UX for these things. So you have this environment where you write your on-chain code, but it's not done. That's not the whole thing, because now you need UX for it. And UX is not just UX, it's client-side logic and UX part of that.
People often confuse UX with UI, and they're very different things. Not just how it looks when you interact with it, but it's what literally is sometimes code and frameworks that are actually presenting that experience.
And our wallet needs a pretty severe rework, like basically a ground-up rewrite. Because the way it works right now, basically whenever new functionality is added to the wallet, it's just cleaved directly into the middle of the wallet, like just deep in there. And that's not great. We want to get away from that. But this framework of doing things right is not something that exists elsewhere. That in Bitcoin, you just don't have smart coins. And in Solidity, in practice, you don't set up your own contracts. Like basically, whenever you do anything, you're just sending funds somewhere, which is really hella scary because your local wallet isn't validating anything. You go to a literal website and just asks you, here, why don't you put in the money? It's yeah, sure, whatever. And you put in the money. And it's very much not your keys, your coins. It's like you're sending money to this thing that you're trusting. And on multiple layers, it's all counter to the whole thing. Anyway, we are trying to do it right and make it so that the local wallet actually has the necessary logic that it is actually in control of these funds, which is something where there isn't really a roadmap from other people, as a result of which our first pass doesn't really do it right. I'm trying to make a framework where whenever you want to add new smart coin functionality, you write your Chialisp and then you write your driver logic to run in wallets that understands these special coins that you're making. And then you write UX to present that, probably with the driver logic being written also in Chialisp and the UX logic written in ECMAScript. Kind of normal stuff here on that level. But we don't have that working yet. So hopefully in the not too distant future, our basic examples will be very nice, simple. Here, right? This, and look, it plugs right into the wallet and works. And we have a long ways to go before we have that working really nicely.
Okay.
Still working.
So to wrap things up here a little bit for this first one, last kind of two questions I want to talk about here. Looking at both stuff we've done ourselves, stuff you've done in your blue sky experimentation, stuff the folks helping you build Chialisp have done, and stuff the community has done.
Yeah.
What's the most interesting or unexpected use of Chialisp so far that you've seen actually implemented and used to accomplish something, whether it be a prototype or an actual product? And when I say unexpected, I don't necessarily mean like knowing everything you know now about what we set out to do. It surprises you now, but like going back several years to planning all this. So it could even be something that you or the team worked on that you just didn't would first think about back in the original days of being something easy to do. Like it could even be something like that.
The most important insights in Chialisp are from a cryptography standpoint, very simple, but they have sort of more business implications than you might expect. So offers was not planned exactly.
Right.
I was designing things in this way for kind of functionality, aesthetic reasons.
Mm-hmm.
And it was only realized afterwards that, hey, we can make offers.
I would argue the offers were very much a great outcome.
Yes. Yeah. No, they are. It shows that
they were semi-unexpected. They were an excellent answer for that.
Yeah. I did not have a great justification for why I was painstaking. Built into the blockchain is this idea that you can net out Chia in total. So when you have these coins that are spent and coins that are created, it doesn't draw straight lines. This coin resulted in these funds. It does have lineage, but the lineage and the amounts don't map to each other very well. The amounts just need to add up. The sum before needs to equal the sum afterwards.
Mm-hmm.
And I was very insistent that the CAT standard have the same property, that it only enforce this and not these funds go here and these funds go there. And it wasn't obvious why I was doing that until we created offers. Oh, okay, this justifies doing all this work. So that was a little bit unexpected. And the other one actually is with data layer, with Merkle trees. That this is a very simple concept, but I just didn't realize how powerful it was before we started working on it. And we really have yet to build out the whole infrastructure that really fully utilizes that power. There's lots of great stuff you can do where there can be a Oracle that's reporting things, a data layer, and someone can make a payment to someone else contingent on a particular thing appearing in that database, and do it in a way where in the clean path, no one else can even see that this dependency was there. Yeah, this is a pretty neat bit of functionality that we're still working on fully fleshing out. And again, it's a not advanced thing from a cryptography standpoint. Like everything I've been working on is in some sense really simple. It's just a lot of subtle engineering stuff. It's very much unlike when I was working on Consensus, which has all kinds of whiz-bang stuff, and it's really fun to work on. And stuff I'm working on now is fun, but it's a lot more like subtle surgery all over the place where there's no super difficult math per se. It's just all really involved and subtle and involves a lot of like asynchronous thinking to wrap your brain around it.
Gotcha. With kind of folding off that, what are some of the most interesting future uses of Chialisp that you're hoping to see in the future that we haven't done and no one else has done yet, but that you were like, I really hope to see this. Is why we built it this way.
Yeah, there's a whole bunch of things. So a thing I always hammer on is better custody solutions.
Yeah. Yes.
So we have our internal custody solution. Naturally, it's our first pass at something. We know how to make it better now. But it turns out the basic functionality is you have a vault, which has a certain number of keys that can access it. And your very most basic logic that you want with a vault is any number of keys can pull things from the vault, but smaller number of keys require longer to do anything. And if some number of keys tries to do a thing, then an equal or larger number of keys can stop them. And this is not that complicated from a logic standpoint. It involves some stuff with time locks and some, again, rather subtle, not difficult, but subtle working out of what all the edge cases are and how they all work. And some careful use of time locks and having the business logic worked out. But sounds, when you just phrase it that way, well, that's obviously very basic, just table stakes functionality. If you are custodying funds, you don't want it to be 3 of 5 can jack all funds instantaneously. You want it to be any number of 5 can take funds out. It might take a certain amount of time. And then a larger number of funds can overrule. And if there's a larger number of keys can overrule. And if 2 different sets of keys of the same size are arguing over what should happen, they deadlock and things just don't move until somebody gives up or somebody finds another key. And this sounds, again, like this is very obvious. This sounds like table stakes once you say it. Obviously, wait, isn't this just basic what every single custody solution does? Otherwise, it's not a real custody solution. It's no, actually, this is very novel. As ridiculous as that sounds. I've always been very excited about making better custody solutions. I fundamentally view
it's really important, because if you look at the largest incidents in blockchain when it comes to the very high dollar amount compromises, they tend to fall into 1 or 2 categories. They are various DAOs that have been compromised because of insecure smart contracts, or they have been wallets that are more often than not just a wallet of someone with a significantly large holdings, but they are wallets that multiple people have access to for business reasons or logistical reasons. And that multitude of access is what led to the series of events that led to someone somewhere not meeting the security standards the others met. And it only takes one at that point. This kind of smart custody solution solves for that greatly.
Mitigates it.
When I say solves for, poor choice of words to use talking about security. It does not 100% prevent it. It solves for in terms of it mitigates the problem, because it creates a solution that is currently lacking to help diffuse the fact that if 9 people share the exact same key to the same wallet, only one of the 9 has to be compromised to get access to it. Now, it's a bit different story.
So this is, I've always been very excited about that. I have always viewed getting that to work well as like job 1 and necessary for really taking over the whole world of payments, which is still on freaking credit cards, which is just
strong feelings there, I take it.
Yeah. It's very frustrating because people don't get excited about having better custody solutions, even though they should. They get excited about more Ponzi.
They get excited about avenues towards easier profits.
Yes.
Which is unfortunately why a lot of the hallmarks of Chia are hit or miss with certain audiences.
Yes. So that's a big set of things that I'm excited about. Also, it's something that's very front of mind for me. Obviously, there's offers. There's having a decentralized exchange there. We're in the process of getting this deployed for high quality carbon credits. That's all very exciting. But we've been talking about that already. So I'll talk about something else. This project I've been talking about that I'm working on is actually peer-to-peer poker, which I'm working on partially just because gaming is cool, but also because we would really like a payment channel network going. And peer-to-peer gaming has multiple benefits here. Number 1, it actually has much greater requirements than simple payment channels. It requires actual full-blown state channels in order to work. So it's getting ahead of the game there in terms of basic functionality. On top of that, second, and possibly more importantly, you don't have like huge infrastructure requirements in order to support these things. A payment channel network requires an actual network, which requires actual counterparties to post a whole lot of money and get this all up and running and working. And that's just a whole lot of work off chain that requires real money and coordination and is a huge pain. If you're doing gaming, like all forms of cheating short of outside assistance can be solved for by doing it on chain. And that only requires 2 counterparties. They just set up a state channel at the beginning of their session and play their session. And then they finish their session and close it out. And that's it. So much easier to deploy. So the obvious approach for us to take, given those facts in the wild.
I have to admit, I genuinely thought before the 60-minute mark, we would have had an answer that you had a way to work in your poker project too. I know it's a huge passion of yours, and it's very interesting every time you talk about it. I honestly thought it was going to find its way into an answer long before now. If I had been a betting man and made bet with people on this, I would have lost all of them.
Okay, I'm trying to not bet too hard.
Fair.
And I'm a little frustrated with my own pace of coding on it. So I'm trying to just get to a point where I'm just really, that's one of these things where I'm dealing with a lot of other stuff because of Gene is dealing with a lot of the operational things, but a lot of any issue that's coming up, architecture and product is my problem. So I have a lot of distractions, but trying to work through that and get
the joys of being a CTO.
Yes. Yeah.
So we're
to carve off time and just crank on it.
So we're going to be doing more of these. Each one's going to get a little more different directions, different focus, different people will be joining us. So thanks everyone for coming to this first one who's been here live in the Zoom call for the actual recording of this. Before we close out, is there any kind of like final thoughts or any last things you want to share or talk about before we go? If not, that's fine. Just giving you the opportunity.
I was just talking about the poker stuff, which is always...
do you want a little 5-minute, 10-minute talk about the poker stuff?
No, the thing I didn't get to that I just started to talk about at the beginning here was how you actually implement capabilities. I did reference it, but it's not obvious that it works, and it's not obvious how this all pulls together.
Okay.
The trick is because you are making assertions about your parent, then when you are spent, you can say recursively either I am a legitimate colored coin or I came from a legitimate colored coin, and it has the rule that it only makes legitimate colored coins as its children, ergo, because I came from a legitimate colored coin, I must be a legitimate colored. And that's the logic that it has. And this is like the trick that the entire system was designed around enabling, was to make this trick work. It's something which, it's weird because I talk to people about it, and it's either completely mysterious or so obvious you can't fathom trying to do it any other way. Like people jump directly from one of those states to the other. So that's my high level point that I always want to get in talking about Chialisp.
Awesome. Thanks for going through all this with me. Thank you everyone else who joined us in for recording this, and to everyone who's listening to this after the fact. This was a lot of fun to do, a fun conversation to have, and I'm looking forward to the future ones that we do. If someone had told me 15 years ago that I'd be working with you on stuff like this now, my first response would have been, who? Because I didn't travel in circles where your name was commonly known to me. If they said the BitTorrent guy, I'd be like, oh, yeah. And then I would be like, no, I'm not. That's not my caliber. I'm not at that part of the world. It is amazingly awesome to get to have these conversations with you about these things now, many years later. The stuff that we're working on here and the stuff that you have spurred is very awesome. And I'm really excited to get to talk about these kind of things. So I'm looking forward to the next couple of these that we do.
Yeah, I don't know how anything I do is ever in the slightest bit cool. I think of myself as a fundamentally uncool person.
I will not challenge or defend your coolness. I will say the stuff that you work on leads to incredibly cool things. This is everything that you've worked on at face value may be not cool in your eyes, but the world it has led to, the things that we can do, the stuff that is available to people definitely is cool. So it is a foundation of a lot of cool stuff that people just may not realize. So I would argue that you do work on cool stuff. That's about all time we have for it today. So yeah, I guess we'll call it there.
All right. Bye, everybody.
Bye, everybody.